All right, guys. This is our video for our first Foldable for our unit since we're back at it again. I hope everyone had a great break. So this is the just folded in half. These are our three sections. We're gonna just kind of review some things that we learned before we left, which is parallel and perpendicular lines, and then writing equations for them. Mostly we did graphing and looking at slopes. So when you open up your Foldable, you're going to see all these boxes and some steps here. So I'm going to start on this top section first, and we're going to talk about what needs to be in here. We're missing that first part, but you're supposed to remember some facts. So some of the facts that hopefully you retained from last semester is that parallel lines are lines that never intersect. They're also lines that have the same slope. So I want you to fill in your Foldable with the key information, underlining key information for you as well to make sure, and I'm using some symbols to make sure you have reviewed that content. Perpendicular lines are lines that intersect, but a special type of intersection. They intersect at a 90-degree angle or a right angle. Okay, and perpendicular lines have negative reciprocal slopes. Okay, and the symbol for perpendicular is the upside down T. So the thing you had to remember with negative reciprocal is first to flip the fraction and then change the sign. So what I wanted to see here, if you could remember how to do that. So if I have 2/3 and I want to do the negative reciprocal of that, that would turn out to be a negative 3/2. 4, it's negative reciprocal. Think of it 4 as 4/1 and then flip it. So negative 1/4. So if I have a negative 4/5, I flip it and change the sign. That becomes positive 5/4 or 5/4. And then the negative reciprocal of a positive 1 is a negative 1. The negative reciprocal of 0 is undefined. Okay. And then our negative reciprocal for negative 3 is 1/3. So pretty much what we ended before the break was just looking and comparing the slopes. So hopefully we recognize if the lines are going to be parallel, perpendicular, or neither just by calculating the slopes. So if I have a line A that passes through, and I'm going to kind of address the key information here. The line A is passing through the point -3, -1, and 2, 3. And then we have line B that passes through the point 4, 2, and -1, -8. So in order to determine if these lines are going to be parallel or perpendicular, we have to focus on the slope using the slope formula. So hopefully remember, if I given 2 points to find its slope, that's when we do y2 minus y1 over x2 minus x1. The change in y is over change of x. So what we're going to do is, and I'm just going to start here, the symbol for slope is this cursive M. I'm going to do the slope of A, line A. And I'm going to show that by doing the difference of my y's first. So that'd be 9 minus the -1 on the top. And the difference of our x's, that would be 2 minus the -3. All right, so when I simplify this, the first thing I'm going to get a positive 10 over 5, which reduces to just 2. So the slope of A, line A, is 2. Now, I'm going to do the same formula for line B. So I'm just going to come over here, I guess. Slope, change my font just a little bit. The slope of B using the slope formula would end up being -8 minus 2, and our -1, excuse me, minus 4. Well, when I do my computation, this becomes a -10. And then on the bottom, we have a -5. Negative divided by negative turns that to a positive 2. And since I see these are the same slope, then these two lines would end up being parallel. Okay, so This should be, nothing really new for you. We addressed the slope formula a lot, so I just want to make sure you can apply it and get the correct answer. So if you want to pause the video and apply the formula to the next two boxes and check your answer, you may do so. I'm going to just take a little pause to fill in a couple steps here and to check to make sure you're on the right track. So I'm just going to do my symbol, the cursive M, to do that slope of A. That ends up being 4 minus a negative 5 and 4 minus a negative 8. When I simplify that, positive 9, positive 12, and this can be reduced to 3/4. For B, so you should have got neither for the next box. And then you check your work on the slope of A and B on the third examples. Make sure you recognize what happens when 0 is in the numerator versus when 0 is in the denominator. So here, this turns out to just 0. I do the slope of B, negative 3 minus negative 9. Wait, no, minus 7, negative 7. You have to remember whenever you have that 0 in the numerator, the denominator at the bottom, this would be undefined. And because we have 0 and undefined, this means this line is a horizontal line, and undefined means it's going to be vertical. All horizontal and vertical lines are perpendicular. So that's what we should have for that last box. Okay. So we're going to take this skill and now write equations for parallel and perpendicular lines. So on your next section here, make sure you have memorized these 4 steps. They're pretty much the same for whether you're trying to determine parallel or trying to determine perpendicular. First, if it's parallel, you need to find the parallel slope, which means we're looking for the same slope. Then we are just going to use our point. So the key information here is we're going to use our given point. Sorry, let me get my pen. This given point is important. And we got to use the parallel slope. So that means the same slope, which is what was said in step 1. Then we're going to plug into our point slope formula, which is right here. Y minus y1 equals m parentheses x minus 1, x minus x1. So this is our point slope form. If you're given the point and you have the slope, you should be using this form. And this is, to me, is the easiest form to use. Let me change that, sorry. All right. Now, in order to solve for y, you might want to add this to your notes. You have to first always, because we have parentheses, you have to distribute. So you're going to first distribute, and then second, you're going to add or subtract, depending on our constant. We're going to add or subtract our y. And I realize I just here, so let me fix this. Oops. That was on there twice. Sorry about that. Let me fix this one. Yeah, there it goes. First distribute, second add or subtract y. All right, so here is our example that I want us to do together, and then I want to see your ability to complete the second one. So we have writing equation of line that is, hold on, let me make sure I get this right. This is what it's driving me crazy. There you go. A line that is going to pass through our point 2, 4, and it's going to be parallel to this equation y equals a negative 3x plus 1. So we have to remember our most important form is slope-intercept form, which is y equals mx plus b, because whatever number is in front of the x, that is our slope. So right there, I'm going to circle always that slope, that number. So that means negative 3 is our m. So m here is going to equal negative 3. We're using the same slope when it's parallel. Our points 2, 7, that represents our x1 and our y1. So our formula for point slope form is y minus that y1 equals m parentheses x minus x1. So we're just going to substitute the parts in. So here is my x1, the 2. That's going to go inside the parentheses here. Sorry. Then 7 is my y1. That goes here in front of the equal sign. And my 3 is our m. Our negative 3, sorry, is our m. And that goes in front of the parentheses. So when I substitute everything in, this will be y minus 7 equals negative 3 parentheses x minus 2. So that took care of step 3, plugging it into the point slope form. Now what you're going to have to do is first distribute. So what's outside the parentheses, anything I see something outside of parentheses, that means I'm going to distribute. So hippity hoppity distributive property. We're distributing the negative 3 times the x and times this minus 2. So keep everything here. Y minus 7, that stays. Now this becomes negative 3x. A negative times a negative now makes that a positive 6. Then now we're going to add or subtract y. Now because this y has minus, you do the opposite. So now it means plus 7 on both sides. That will cancel, leaving us the equation y equals negative 3x plus 13. And that is our equation for the line parallel to the equation that was given, y equals negative 3x plus 1, through the point. So this is what we're looking for. Okay, so what I want to see if maybe possible you can do is follow the steps for this second one. Okay, see if you can get to the key information, which is your point and your slope, which is 4/3. We're using the same slope. So x1 is the negative 3, y1 is the negative 1, and your m equals 4/3 because we're doing the parallel. Okay, try that one. Just pause. I'm obviously going to ask to see if you get to the right answer. Okay, and then we'll talk about our last type. So after you've worked this out, come back with me as we now talk about the last way to find the equation of a perpendicular line. So we're still going to look for our negative reciprocal slopes whenever we're dealing with perpendicular slopes. Okay, so negative reciprocal, this is when we flip and then change the sign. We're still going to use point slope form, which is down here. So we're plugging in our point for x1, y1, but we're using the perpendicular slope, so that's when we have to flip and change sign. I'm probably should change my font. Change sign. And then now we're going to use the point slope formula, and then we're going to do the same thing, solve for y. So you take the same key information. There's our point. Here, we want perpendicular to this equation. So if y equals a negative x plus 5, hopefully you remember that's an imaginary negative 1 in front. Let me make that one a little bit better. So that means that's the slope. M is a -1. Sorry. But we're looking for the perpendicular slope. Remember, upside down T is the symbol. So that would be a +1. So this is what we're using in our formula. In our point slope formula, which is y minus y1 equals m parentheses x minus x1. We're now just plugging in the parts into the formula. So our y1 is our -4. You got to remember, when you plug it in, you're going to do the opposite, because we're not going to write y minus a -4, because we can simplify that as just y plus 4 equals our +1 for m parentheses x minus 3. Now we need to distribute first, because we're going to do the last step, which is solve for y. And when we distribute, we get y plus 4 equals 1x minus 3, or just x minus 3. And then we solve for y by doing the opposite, which is -4. So these cancel, so y equals x minus 7. And that's our final answer. So I want to see if you can get to the equation for the second box. And then what you were going to address mainly in class, but you can kind of get started on it, is some more practice. Okay, so we're going to do some more practice, and then we'll have some homework with this. The first set of our more practice is writing an equation that passes through the point. Oops, I probably need to change that. Passes through the point that is parallel to the given equation. Okay, so obviously our point here, this represents our x1 and our y1. In the equation here, our slope is 2, and we're just doing the exact same steps that we have in our foldable. We're going to plug everything in first, so this would be end up being y plus 1 equals 2 parentheses x plus 4, and then we should be distributing and solving for y. So the first set here, we're using parallel. First 4. The next 4 is going to be perpendicular. Now, in order to see our slope, just kind of review something real quick. This is not in slope-intercept form, which is mx plus b. I have to have it in this form so I can see the actual m, which is a slope. So in this example on number 7, the first thing you're going to need to do is change it to that form by solving for y. So that means you have to do the opposite, or move the ax term by doing the opposite of the x term. So if this x is positive, I'm not doing negative. Rewrite everything, -2y. Write the x term first, which is -x plus 14. And now to solve for the y, we divide everything by exactly -2. And by doing that and simplifying this, this will be written as 1/2 x, it's positive, minus 7. And now you can see the slope to put it into your point slope form. Okay, so once you try these, like I said, we're going to go over this in class and then let you have some class time to start on your homework. Thanks, guys.